He was such a noble dude. I blow up to smithereens. Could be the
Hey
rabbit.
everyone, welcome back, and let's write some more neat code today. So today let's solve minimum, or if it's empty, then what I'm going to do is return an empty string because that's just how they want us to handle it in this problem. And I'm going to have two windows that I showed previously, so count of t and just the current window that we have. They're both initially going to be hash maps. They're both initially going to be empty. And the first thing I want to do is initialize our count t map because we know this map actually isn't going to change at all. So for every character in string t, I'm going to add 1 to it, but the value I'm going to get, I can't just do this because it's possible that C hasn't even been added to count T yet. So I'm going to do some Python stuff. I'm going to use the function get, which is good for this. So I'm going to get C. I'm going to get the count of C. So if C exists in our map, it will give me the value that's stored in here. Value I'm going to get, I can't just do this because it's possible that C hasn't even been added to count T yet. So I'm going to do some Python stuff. I'm going to use the function get, which is good for this. So I'm going to get C. I'm going to get the count of C. So if C exists in our map, it will give me the value that's stored in here. If it doesn't exist, I can put a default value, which is going to be 0. So if it doesn't exist, this function will return 0. So that's just a way that I like to handle this case. So now that we've initialized the count of t, we can have our variables have and need. So we know have initially is going to be 0 because we have 0 of the characters we need, and need is going to be initialized to the length of count t because that length of count t gives us the unique characters in the string t. And then I'm just going to start iterating through every character in S. So I'm going to use a right pointer for that. The R is going to tell us the right boundary of our current window. So I'm going to get the character that we just reached, which is S at index R. So I'm just going to put it in a variable C. So with C, we know we can update our current window. So I'm going to do window of C and add 1 to it for the character that we just reached. And here I'm basically doing what I did above. If C has never been added to window, we're just going to return 0 with this function. So 1 plus 0, we'll put a 1 here. If it does already exist, this function will get us the count that was stored in here. So we're updating our window, we're adding the count to it. Now we want to know, does this count completely satisfy what we were looking for? Does window of C equal exactly count of T? That means we just satisfied a condition for the first time. But one thing I also want to check before I check this is that C is even a character in count T. So if C is in count T and this is true, because we know we don't actually care about the characters that aren't even in the string T to begin with. And we know if this is true, we can update our have count, so we can increment it by 1. This means we just satisfied a condition. So now what we want to know, does have equal need exactly? So are they actually equal? If that's true, I'm going to run a loop, and I'm going to show you why it needs to be a loop. So if we actually met the condition, let's, 1, update our result potentially, right? So if we found a new minimum result, let's update. So this actually reminds me that I didn't even set a result. So let's set our result and our result length. So initially, we know our result is going to be a pointer, like a left and right pointer. So I'm just going to give it a default value of -1, -1. And for the result length, I'm going to put float infinity because that's a good default value in this case because we are looking for the minimum string. So any value will obviously be less than infinity. And I'm also going to initialize a left pointer because we know R tells us the right pointer, left pointer will initially be set to 0. But so now we can actually update our result. We know the condition has been met. So if the current length of our string, which is going to be R minus left plus 1, this is how you just calculate the size of our current window. If it happens to be less than the current result length, which initially starts at infinity, so this will definitely execute at least once. If this is true, we can update our result, which is stored over here. So we can set our result to left and right. This is the window, and we can set our result length equal to the size of this window, which we just computed above, but let's compute it again. This is the size of the window. And just like I showed you in the drawing, while the condition is met, we want to keep shrinking from the left. We want to make this string as small as it can possibly be. So let's pop from the left of our window, right? Let's try to minimize it. So I'm going to remove the leftmost character from our window map. So the leftmost character is the string at index left, right? And from this, I'm going to decrement it by 1. So now, since we removed a character, it's possible that our have and need condition is no longer met. So I'm going to do something something similar to what we did up here. I'm going to check if this character S of L was in count T, meaning it's one of the characters that we need to satisfy our condition, and if somehow right now, for the first time, that we took this character from our window and now the count is actually less than the count that we need, which is present in count T. So now if by removing a character we just made it less than what it needed to be, what we did is we just took our have and then decremented it by 1. Right, so this is just a part of removing a character from the left. We update our map, we update our have count if we need to, and lastly, we take our left pointer and increment it by 1 because of course we have to shift this by 1 if we're removing a character from the left of our window. So now, after we do this, we're going to potentially check the have and need condition, and it might be true, it might not be true, and whatever it is, the loop is going to execute when it needs to. So this is all we're doing. We're taking characters, adding it to our window map, checking if the condition has been met, updating the window accordingly. That's all we need to do. By the end, the result, if it exists, will be stored in our result variable. So our result pointer, we can put it in left and right. We can take result and extract it into left and right. These pointers in this case, these new left and rights will tell us the result. So what we can do is say return from string S going from pointer left all the way to pointer right, but we need to add 1 for the off by 1 error. And we're only going to do this if the result length has been changed, meaning it's no longer infinity, because we know it's actually possible that a result does not even exist. If that's not true, if a result doesn't exist, we know we have to return an empty string. So there it is. This is the entire code. I'll probably have to
Yeah. Um,